All right, we're going to try to take some notes over graphing square root functions this morning. First thing we're going to do is fill in the table and graph a square root function. So we're going to start, and if you remember, let me back up. If you remember, when you put a negative under the square root, you don't actually get an answer. We're taking the principal square root, which is a positive value. If you put that in the calculator with a negative, we end up with a non-real solution. So we can't end up with a negative under the radical. So we're going to start with 0. And what we're looking for here is this is going to be the square root of x. So the square root of 0, whatever we pick for x, in this case is 0. So we'll graph the point 0, 0 on the graph. The next number we can take an even square root of would be 1. So the square root of 1 is 1. And we'll end up with a point of 1, 1 on our graph. This is the basic parent function of the square root of x. Then we have the square root of 4. I could have picked 2 and 3 as x's, but I can't take a nice even square root of those. So I'm going to jump to 4. So I get a 2 when I take the square root of 4. So I'll have a 0.42 on my graph. And then the last thing that will fit on the graph that I can take the square root of is 9. And so the square root of 9 is 3. And now I've got 4 points. So I'm going to go over to my graph and put those points on the graph. We'll start out with 0, 0, then 1, 1, then we'll go over 4 and up 2, and over 9 and up 3. And our graph will look like this. Okay. Now when we look at that graph, we look at our domain and range. Remember, domain is the x values and range is the y values. The lowest x value is 0. So we have the square bracket with the 0. And it will go out all the way to the right, so that would go to infinity. And the range also starts at 0 and goes to infinity. Now this domain and range can change as this basic graph is translated or shifted up, down, left, or right, or it can be reflected over the x-axis, reflected over the right axis, or the y-axis, excuse me. And we'll do that in the next few slides. Now I want you to get your graphing calculators out. Be sure the stat plots are off. Check to make sure that there's nothing in your y equals. If you have trouble graphing, perhaps you can ask a classmate to help you get started. But I want you to plug these next few graphs into your graphing calculators. And all the time, remember where our original graph, our parent function, falls in relation to these graphs. Okay, so we're going to first look at this negative square root of x. So I want you to put that in the calculator. And I'm going to draw on here, this first graph on this page, the basic parent function. So it'll remind you where that is. And if you'll notice, your negative square root of x, when you put it in your calculator, is a reflection over the x-axis, and it's going to fall. It's going to go, instead of up and to the right, it's going to go down. It's a perfect reflection. We have a point at 1, negative 1, at 4, negative 2, and at 9, negative 3. It didn't shift. So this is graphed in this pink color. Okay. So it didn't shift left, right, up, or down. It's just a reflection over the x-axis. Now when we graph x plus 5, and I'm going to graph that one in red, you're going to notice, again, notice where your original function is. This x plus 5 takes that original function and moves it to the left 5 units. So instead of starting at 0, 0, now you start over here at -5. It just slides the whole thing over 5 spaces to the left. But then from there, from our new starting point, I still go over 1 and up 1, over 4 and up 2, and over 9 and up 3. So you can still kind of take those original points, you just have a new starting point. And that would be what the graph of the square root of h plus 5 looks like. So plus under the radical shifts it left that many spaces. Now, as you would expect then, the number, when it's a minus, is going to shift it right. That seems a little bit backwards for plus to go left and minus to go right. But if you remember when we did quadratics, when it was grouped in the parentheses with the x, that's the way the transformation occurs. So we'll shift this one right 1, so there's a new starting point. There's no negative in front, so there's no reflection. So it looks just like our parent function, just scooted over to the right 1. So we have a point, a new starting point, over 1 up 1, over 1, 2, 3, 4 and up 2, and over 9 and up 3 from our starting point. And there is our new shifted or translated graph. Now when we have the square root of x, there's nothing else under the radical sign with that, and a -8 out to the side, that's going to be a downshift. So it goes downward, in this case 8 spaces. So instead of starting at 0, 0, we start way down here at -8. And that's our new starting point for our square root graph. From there, we're going to go over 1 and up 1, over 4 and up 2, and over 9 and up 3. And draw in our translated graph. Alright, so hopefully you're putting these in the graphing calculator as we go. If I'm going too fast, you can stop the recording, take time to enter it and see what happens, and then go on. Alright, now we have a +3, so as you would expect, this is the same square root curve, but it's going to move up 3 units. So our new starting point is 3 units from the origin, up. Then we go over 1 and up 1 from the starting point, over 4 and up 2, and over 9 and up 3. And draw it in. Okay. Now the 2 in front here in this next problem is a vertical stretch or compression. If there's a number, a multiplier underneath the radical, that's a horizontal stretch or compression. We're not going to do those in this lesson. We're just going to look at vertical stretches or compression. And that number is out in front of the radical. What that means is your y, every y, is multiplied by 2. If there was a 3 in front, it'd be multiplied by 3. There's no left or right shift or up or down, so our starting point is the origin. But instead of going 1 right and 1 up, Now we're going to go 1 right and 2 up. It increases 2 times faster than it did before. And instead of going 4 to the right from our starting point and up 2, now we're going to go up 2 times 2, or 4. Again, went twice as high as it did before. When we go over 9, instead of going up 3, we're going to go up 6. And you can see this graph definitely increases much more quickly than our original graph, which is the square root of x. Now these last ones are something that's different. When the negative is inside the square root, that is a reflection over the y-axis. Outside the square roots reflects over the x. So in other words, there's no left, right, up, or down shift. I'm going to go start at 0, 0, and I'll go left 1 and up 1, left 4 and up 2, and left 9 and up 3. And this causes a reflection over the y-axis. Now this could be a little confusing because you're used to seeing that a negative under the radical would give you an imaginary number. So let's look at a table here and show why this is a reflection. So if I have the square root of negative x, in other words, if I had a 1 there, I couldn't take the square root of negative 1. That's why it doesn't go in the positive direction. I have to have, let me erase those. I have to have a negative value for my x. So if I have a negative 1 value for the x, then a negative square root of negative 1 is positive 1. And so my point is negative 1, positive 1. If I have a negative 4 for x, then I have a negative 4, which is 2. So I have a negative 4 and up 2. And so that's why you can have the negative, because you're really taking the negative of a negative number, and that's why it causes the reflection over the y-axis. Okay, now what if we have something like this, where we have 2 minus x? Well, I think the best way to think about this is to factor out your negative. This is the same as the square root of negative x plus 2, which then if I factor out the negative is the square root of negative x minus 2. Okay? That way we've taken the negative of what, this is the easiest way to see the correct transformation. Okay, so x minus 2 is typically shifts everything right. And that's what happens here. So we shift right 2, but it's a reflection over the y, so instead of pointing to the right, it's going to point to the left. So we'll go left 1 and up 1, left 1, 2, 3, 4 and up 2, and left 9 and up 3. Okay. And there's our graph. Okay. So don't let those negatives under the radical confuse you. They're a little harder than some of the other transformations. So let's kind of review this and summarize it. We're going to remember what the effect on that original parent function was when we put the square root in front That's a reflection over the x-axis. Okay. When we have x plus h under the radical, that shifts our whole graph left h units, whatever h is. And if it's minus h, it shifts our whole graph right h units. When there's a plus k outside that's not under the radical, if it's plus, it's up k units. And the minus k outside shifts our graph down k units. Okay. The A in front is a vertical stretch by a factor of A. Now, if that number is bigger than 1, it makes it get taller faster. If it's between 0 and 1, it tends to flatten it out. Okay, so that's a vertical stretch by a factor of A. Now, the negative underneath the radical causes a reflection over the y-axis. And if you have it, something that looks like this, remember the easiest thing to do, I think the best thing to do is to change it. So you factor out your negative. So that's negative x minus h would end up being a reflection over y and a right shift. I'm listing these separately because I do think the left and right shift when you have the reflection is a little bit confusing. So we're going to go and again factor out our negative on this other example, and that would leave us with x plus h, which is a reflection over y, but a left shift. Okay, and so there's a summary of the transformations that we've talked about in this lesson. So you can use this if you need to as you do your homework that's on My Open Math. But let's go on and do a few more things, a few more examples. This is taking all of this and making a graph. You notice, let's talk about what the shifting we see is. We've got a reflection over x because the negative is in front. We are going to move it right 3 units and up 4 units. So let's do our shifting, our horizontal and vertical shifting first. We go from our starting point, which is at 0, 0 normally, and we're going to go right 3 and up 4. So we're going to move it right 3 and up 4. And there's our new starting place right there. Now we know it's a reflection over x, so instead of going up and to the right, it's going to go down and to the right. So from that starting point, we'll go down 1 and over 1, or over 1 and down 1, and then over 4 and down 2. And I can't get any more points than that on the graph, so I'm going to go ahead and draw my square root curve. Now let's look at the domain. The lowest value of x that we see is a 3. So our domain starts at 3 and goes to infinity. The range, however, the lowest number, since it's going down continually, the lowest number is negative infinity. And it goes up, the highest number is 4. So remember, sometimes you have to adjust your range depending on which way the graph points. And the domain too. Alright, so let's look at one more graph example. This one has a vertical stretch. There's no reflection, there's no negative in front. So it's a vertical stretch by 2. It's going to go left 1 because of the plus 1 under the square root, and down 3 because of the minus 3 outside. So let's start. Let's first get our new starting point. And our new starting point is going to be from the origin, left 1 and down 3, which is right there. Now we have a stretch, so for every, we multiply all our y's that we normally do by 2. So instead of going over 1 and up 1, we go over 1 and up 2. We go over 4 and up 4 instead of 2. And we go over 9 and up 6 instead of 3. And so there is our new graph. So it's easy to graph if you can recognize these translations. You can put them in the graphing calculator, but if you don't have a graphing calculator, it's not necessary. Alright, so our new domain, the lowest value of x is negative 1, and it goes to infinity. And in the range, the lowest value of x is negative 3, lowest value of y, and it also goes to infinity. So there's a couple examples of some graphs where we did several translations. You're going to have some homework that you have to do a little bit of this on. Now the last thing I want to do is to talk about writing equations, giving the transformations, or looking at a graph. So we're going to start our equation with y equals. Okay. Now we're going to go 2 units right, which means that's under the radical, and 4 units up. So with the square root, 2 units to the right would be x minus 2, and 4 units up means outside, and be sure I can tell that it's outside and not underneath the radical. You have plus 4. On the number 22, we're going to shrink by a factor of 0.5 and 3 units up. Vertical stretches and compressions are in the number in front, so there's going to be a 0.5 there. Square root of x, there's no left or right, so we just leave it the square root of x. And then 3 units up is a plus 3 outside. Then we reflect across the x-axis We also have a vertical stretch and a 1 unit down, no left or right. So we start with y equals. X-axis reflection is a negative in front. We have our vertical stretch that also goes in front. We have to have what the function is, which in this case is a square root function, and then 1 unit down, which is -1. And I didn't write this, but since we're doing square roots, we're using as our basic function that we're transforming f of x equals the square root of x, or y equals the square root of x. Now we've got two more. This one we want to reflect across the y-axis, a vertical stretch by a factor of 2, 5 units left and 3 units up. So this has a lot going on. So first y equals. The vertical stretch is in front, so it's a factor of 2. Now we have a y-axis reflection. So we have a negative under there, under the square root. Then I'm going to put parentheses and write my shifting just like I normally would. 5 units left would be x plus 5. And then we're going to shift 3 units up. So we have a plus 3 outside. Now if you wanted to write that without the parentheses under the square root, you would just say y equals 2 square root of negative x minus 5. You would just multiply, distribute that negative across, and then have your plus 3 outside. And this last one we're going to go by a graph. So we have to look at our new starting point to tell us whether we can see it doesn't start at the origin. So let's see, we've gone from the origin left 2 and up 2. So we can start by writing that in. Left 2 would be x plus 2, and up 2 is a plus 2 outside. We see that we have a reflection. It's over the x-axis, not over the y-axis. So that means that my negative is in front of the square root. Do I need to have any kind of a vertical stretch? Well, we go down 1 and over 1, down 2 and over 4. So it doesn't looks like there's no stretch to take into account. So we just have our negative in front to show the reflection.